Hi, so for today, we're going to talk about determining or determination of integrating factors for non-exact DE. So I already had a video about this non-exact DE made exact by integrating factors. So if you haven't watched that video, you can watch it first, then you can watch it here. Okay, it doesn't matter. We're going to recall the basic concepts, okay, or the formulas in our non-exact DE made exact. Okay, so if we wish to recall, we may be using this formula, the two formulas for case 1 and case 2, okay, of determining the integrating factor. So now we have the formula 1 all over n, where our differential equation is still on the form of m of function of xy plus n sa function of xy dy equals 0. And that m or n here is that definition of n multiplied by the partial of m, okay, multiplied by the partial of m all over y minus partial of m with respect to x, which is actually this is the test for exactness. Okay? If they are equal, then they are exact. Okay? But in this case, they are not equal. So if we subtract this, okay, actually, and multiply it by 1 over n, we get a value of f of x, of which that f of x, purely in terms of x or any constant, okay, we can use it to now identify the integrating factor. So we have e raised to f of x dx. Now, we will be using this first formula if we can express the what? The the f of x in terms of purely x or a constant value. Okay. However, if we can express that in terms of purely f of y or purely in terms of y, we must be using 1 all over m. Okay. And then we have the integrating factor, a little bit different. We have a negative here, e raised to negative integral of f of y dy. So again, this is case-to-case basis. Okay. Which one we will be using? Is it either n or m? Okay, so based on the given problem. Okay, so let's get started for us to realize this. Okay, so if we get the partial of m with respect to y, okay, this is our m. Let's get it the test. Let's get a test for exactness. Okay, so that we can identify this that this is not an exact PE. So if we get the partial of m with respect to y, this will be 4x plus 6y. Okay? So how about the partial of n with respect to x? So this is equivalent to x squared. Okay? So if I distribute x here, so n, I would rewrite first the n in terms of xy. I distribute x. So I have x squared plus 2xy. Okay, that is our n because of x here, not we distribute the x. So partial of n with respect to x would be 2x plus 2y. You see, they are not equal, then therefore this is not exact. Okay? So what are we going to do is to determine the integrating factor IF, because this integrating factor, when multiplied on the whole equation, would make the equation or our differential equation exact. So that is very important. So now, we will perform partial of m with respect to y minus the partial of n with respect to x. Okay? We perform that first. Okay? This formula before we decide what are we going to use, 1 all over n or 1 all over m. So we have 4x plus 6y minus 2x minus 2y. Distribute the negative sign. So 4 minus 2x is 2x. 6y minus 2y is plus 4y. So 2x plus 4y. Now, if we are going to look at our n, we have 4xy plus ty squared minus x. So if we use our m, for example, 1 over m, we would not be able actually to express that purely in terms of y. Okay? Because we have minus x here, we have y squared here, 4xy. But rather, we can express that in purely in terms of y or a constant, okay, if we use 1 all over n. So if we perform 1 all over n, partial of m with respect to y minus partial of n with respect to x, that would be simply, this is multiplied by 1 all over n. So our partial of m minus, with respect to y minus partial of n with respect to x is 2x plus 4y. Okay? Over, over, wait, 2x plus 4y all over this n. Okay, this n. So I will get this factored form n. Okay, so that we will be having a hint, okay, on what will happen. So as you can see, if I am going to uh, uh, factor out 2, okay, on the numerator we have x plus 2y, and therefore we have x all over x plus 2y. This should cancel out. And we are able to express this function, okay, in terms of purely f of x. So if we divide that by m, we would not be able to produce a function purely in terms of y or constant, given its given here, 4xy plus ty squared minus x. So it's a case-to-case basis. So my suggestion is first, perform the partial of m with respect to y minus partial of n with respect to x and see the difference before you decide what you are going to choose. Is it m or n? So our f of x therefore is equals 2 all over x. Therefore, our integrating factor from our formula, since we use 1 all over n, we will be using this formula, the first formula. So we have e raised to 2 all over x, that is our f of x. Okay, e 2 integral of 1 all over x dx, or simply that's e raised to 2 ln of x. And by properties of ln, we can put this 2 on the exponent of whatever is the inside function in ln. So we have e raised to ln x squared. So e raised to ln would cancel. So our integrating factor is x squared. Okay? So the second step that we are going to do, we copy the, now that we have already the integrating factor, what are we going to do is to simply multiply this integrating factor on the whole equation. Okay? On the whole equation of the given. Because this would make the equation exact. So if I'm going to multiply x squared, okay, x squared. So we have 4x cubed, y plus 3x squared, y squared minus x cubed of dx. Now, this is our new m in terms of xy. Plus, we have x cubed multiplied by x plus 2y dy. Okay, so if I'm going to distribute the x cubed here, what will happen? This becomes x raised to 4 plus x 2x cubed y dy equals 0. So this would now be our new m in terms of xy, and this would be our new n in terms of xy. So, shall we perform again test for exactness to make sure that this is now exact? Partial of m with respect to y would be 4x cubed plus, consider this as a constant, okay, differentiate this. So we have 6x squared y. With respect to y, this is 0, the x cubed, because that is considered as constant. So partial of m with respect to x and with respect to x, so we have 4x cubed. Okay, with respect to x, that is 6x squared y. So therefore, they are now exact, and we know how to solve exact equations. If you haven't watched my video, please watch it first. So how do we do this? We have partial of f, okay, and then integral of mxy dx. So we have f. Our f is 4x cubed y plus 3x squared y squared minus x cubed dx. Okay, so distribute the integral sign and the dx. So we have 4x cubed y dx plus integral of 3x squared y squared dx minus the integral of x cubed dx. So shall we continue our solution here? Okay. So I can factor out all the constant, including the y, because I am integrating with respect to x. So I can factor it out. So you have 4y integral of x cubed dx plus we have 3y squared integral of x squared dx minus integral of x cubed dx. So finally integrate, we have 4y x raised to 4 all over 4 plus we have 3y squared here, x cubed all over 3, minus we have 1/4 x raised to 4 plus we have a q of y, a function containing purely in terms of y because we have integrated in x. So this q of y is considered as a constant. So we have cancel this. Okay. Therefore, we have x raised to 4 y plus y squared x cubed minus 1/4 x raised to 4 plus q of y. That's the value of our first f. Okay. Second f, we have partial of f. Okay. Integrate with the n of xy dy. So we have f here. Integrate the n. So we have x raised to 4 plus 2x cubed y dy. I can factor out, okay, distribute y and factor out x. Okay, so we have x raised to 4 dy plus integral of 2x cubed y dy. So what's next? Factor out x because we are integrating with respect to what? Y. So we have x raised to 4 integral of dy plus 2x cubed integral of y dy. So our answer would be x raised to 4y plus 2x cubed. We have y squared all over 2 plus a function purely containing in terms of x because that is considered as a constant. So we have cancels the 2 here. And then we have x raised to 4 y plus x cubed y squared. Okay. Plus r of x. And that is another f. So as we can see, if we are going to equate these two to determine the value of q of y and q of x, so we have this. So if we determine the value, we have q of y. Okay, this would cancel first, x raised to 4y. Then we have positive x cubed y squared. Q of y, are there any function on the other side of the equation purely in terms of y? We have none, so therefore that is 0. R of x, do we have a function here on the left side of the equation purely in terms of x? This is negative 1/4 x raised to 4. So therefore, our answer can be what? Drawn from this f, provided that we will have the plus q of y, or this f, provided that we will write the plus r of x. So since this f, q of y is 0, so therefore the answer is this. Okay? So we have, although we can also use this, provided that we add the r of x, which is negative 1/4 x raised to 4. So the answer would be x raised to 4 y plus x cubed y squared minus 1 all over 4x raised to 4. I've used this first f. Okay, plus 0. I would not write that. 0 because of q of y. And the right side would be equal to the value of c. Okay, and multiply this by 4. Okay, to eliminate the denominator here. So we have 4x raised to 4y plus 4x cubed y squared minus x raised to 4 equals c. 4c would be equal to c. Still c. Okay? So let's get to number 2. Okay? Number 2 problem. So we have y squared dx plus 3xy plus y squared minus 1 dy equals 0. So first, test for exactness. Obviously, this would not be an exact. Partial of m with respect to y, that is 2y. Partial of n with respect to x, that is 3y. Okay? So therefore, not exact. Not exact. So this is not an exact. So we get the difference of partial of m with respect to y and partial of n with respect to x. So we have 2y minus 3y, and that is negative y. Obviously, what are we going to use? Is it the n or the m? 1 all over m or 1 all over n? Of course, this 1 all over m. We're going to use 1 all over m, partial of m with respect to y minus partial of n with respect to x. So that would be negative y. This is multiplication with 1 over m, so that we have y squared. So as you can see, this would cancel. So we have negative 1 all over y. And that is the value of our f of y. And remember, from our formula a while ago, that the integrating factor would be e raised to negative integral of f of y dy. We have a negative here because we have used the m. Okay, so we have e raised to negative of the negative of 1 all over y. As you can see, I can factor out the positive or the negative so that it becomes positive. So that we have dy all over y, or 1 over y multiplied by dy. So this is very simple. We have e raised to ln of y. E raised to ln would cancel. So we have an integrating factor of y. So again, what are we going to do is to multiply that y, okay, by the whole equation. So if we multiply that, so we have y here. So we have y cubed dx plus 3xy squared plus y cubed minus y dy equals 0. So if we get the partial of m with respect to y, so that would be 3y squared. Partial of n with respect to x to test whether it is exact. So you have 3y squared, partial of x, so y would be considered as constant, plus 0 minus 0. So therefore, we have an exact DE. Okay? So, you know how to solve that. Partial of f, we have integral of m of xy in terms of dx. So this would be f integral of y squared dx, because our m is, that should be y cubed, because this is now our new m. This is our new m. This is our new n. Okay? So we will be looking at this equation after that we have already multiplied the if. So we are integrating with respect to x. So factor out y cube outside of the integral sign, and the integral of dx is x. Y cube plus q of y. How about the other f? So we have integral of n in terms of xy. We have dy. We have f. Integral of n is 3xy plus y, 3xy squared plus y cubed minus y. We have dy. So we are integrating with respect to y, so I can factor out all the values of x and the constant. So we have 3x y squared plus integral of 3xy squared dy. So I have dy here plus integral of y cubed dy here minus integral of y dy here. Okay, so integrate. So we have 3x y cubed all over 3. This would cancel. Plus, we have y raised to 4 all over 4 minus y squared all over 2 plus the r of x. Constant purely in terms of x because we have integrated with respect to y. So equating our 2m, this is 2f, this is the first f, and this is the second f to determine the r of x and q of y. So let me just simplify this. This would become, the first f is xy cubed, okay, plus q of y equals, take note that the 3 here cancels. So we have x y cubed plus y raised to 4 all over 4 minus y squared all over 2 plus the r of x. So if we're going to determine the r of x or the q of y, the q of y is a function purely in terms of y on the other side of the equation. So we have y raised to 4 all over 4 minus y squared all over 2. But the r of x on the left side, are there any term here that purely contains in terms of x? So no. So we have 0. So therefore, our answer, okay, I could rewrite this because this is only 0. So we have xy cubed plus y raised to 4 all over 4 minus y squared all over 2. Then we have equals c. So I can multiply this by 4 so that we have 4xy cubed plus 4y raised to 4 minus 2y squared equals c. Okay, so this would be our answer, our more simplified answer. And that's it. Again, for the non-exact DE determination of the integrating factors to make the DE non-exact DE an exact DE. So, I will be uploading again a part 3 of this video for more complicated examples. So, I hope you learned something for today's video. Thank you so much. And again, see you again. This is Engineer Abat. Please do subscribe to my channel. Thank you so much and God bless.